So yes, as I was saying, the external resistance is this resistor right here that you see outside. And the reason why they are saying external resistance is because sometimes you'll have internal resistance. You'll have internal resistance that is normally connected there next to the cells or your battery. So normally it's connected there. Then it will have another volt drop there, which is your V1, and then this one will have V2 there. So that one that is connected next to the cells, that's your internal resistance. Internal resistance. And then this one right here is your external. So we'll get to that. So any change in the external resistance will affect your external potential difference. So when they say external potential difference, the external potential difference is the voltage, this one. They sometimes call it external potential difference. Sometimes they call it external resistance. This one will have a potential difference. So potential difference is just the volt drop. It's just the volt drop. So they say increase in the external resistance of the circuit will cause the external potential difference to increase. Remember what I told you. I told you that when resistance increases, the current drops. Resistance increase is equals to current decrease. But equals to any change. Remember, whether you increase resistance or current, the voltage increase. Because you increased the resistance, voltage increase. So you can simply say resistance is directly proportional to voltage or potential difference. Okay. So normally you have to calculate the EMF. So you'll have a circuit like this with the external resistance R, then with the cells there, something like this. Then with the external resistance, I'll write R. Then you'll have something like this. EMF, they'll ask you to calculate the EMF. EMF, electromotive force. EMF means electromotive force. I'll explain what is that later on. So this is your EMF. The reason why I'm doing this, remember these cells alone, you can say it's a potential difference. That those cells alone, I'll highlight them in blue so that you can see them. This alone, without the external resistance, without the internal resistance, that R, small r, is a potential difference. But with that, if you have internal resistance on your calculation and also the external resistance is your EMF. So EMF is the total voltage across everything. Remember that resistor, you'll have V1, and also that small resistor, you'll have, let me just say this one is V1, that one is V2. So you'll have a voltage on that small resistor, which is your internal resistor, and you'll also have a voltage on that resistor, the bigger one, the external resistor. So EMF is the total resistance, the total voltage of every resistor. So resistor R1, remember that resistor R, the bigger one has got a voltage, let me just say V2. This one is a voltage V2. So it will have a voltage, then also that one will have a voltage. So we'll name it V1. But remember, for a series circuit, current is the same. Then voltage is not the same. You know why the voltage is not the same? Because you have to calculate a volt drop V2 and V1. So you calculate a voltage for each resistor. Calculate for each resistor individually. Each resistor will have a volt drop. That's why voltage is not the same, but the current is the same. So let's say a current on this circuit I is equals to 2. So 2 amps. So the current there, it will be the same for R, small r, which is your internal resistance, and also the bigger R. It will be the same throughout. It will be the same for everything. So remember, EMF is the total voltage, so it's V1 plus V2. So it's the combination of voltage across that internal resistance and the voltage across that external resistance, which is your R, the bigger R. So remember, V1, to calculate V1 means it's current times resistance. So you're gonna use, because I said the current is the same, I1. Let me just name this current I1. Because it's a series circuit, the current is the same. So meaning I1, that I1 will be the current that's gonna flow through that internal resistance. So you're gonna have I1 times small r plus the other one, which is your V2. V2, it's I1 again, I1. Remember to calculate, oh sorry, let me not combine them. So to calculate V2, you're gonna have I1 again, because it's a series circuit. It doesn't split, it's only series. So you're gonna have R there. So how do you know that it's a series circuit? Because there's no branch. If it was branching out somewhere there, and then you put another resistor, as long as you see a branch there, it means it's a parallel. So there's no branch on this one. I will explain the parallel circuit after this. So this one is a series circuit. Then you'll have a bigger R. So this means that EMF is the same as V1, which is your I1 R plus I1 bigger R. So that's how you calculate the EMF. So before you can find the EMF, you need to know the internal resistance. So I'll also explain the internal resistance before I do the parallel circuit. So the internal resistance, you have to consider the losses, the V loss. You have to consider the V loss.